Hello and good morning and welcome to the PrimeKey webinar, What's Inside the SEE. We see that some participants are just dialing in, so maybe we will wait 2 seconds for them to join our conference and then we will start immediately. Okay, I think we should start to make it in time. Again, welcome to the webinar from PrimeKey about the secure execution environment. And before we start, some information about myself and some housekeeping stuff. So my name is Andreas Philipp. I'm working at PrimeKey in the business development team, and I'm based in Aachen, Germany. I'm working around about 30 years in the area of IT security. Started as a developer. I coded around about 15 years. And after this, I moved over and I start working in sales and business development. And that is what I'm doing till today. Beside me and behind the scene, we have a co-host, Evangelos Popes, the sales director in the DACH region. He is picking up all the questions that you can post on the right side of your control panel of the GoToMeeting stuff, and there you can have a section question, and there you can post question. And after the presentation, we will answer, or we will try to answer every question. So let's start. What's in today? So today on the agenda, we will talk about the secure execution environment at PrimeKey. First of all, we will make a short motivation why we think it's time to change the security focus and why we think application security will be more and more getting into the focus of our economy and our IT environment. Then after this, I describe you the concept of the secure execution design, secure execution environment, and we will talk about the overall design of this product and to understand the technology and to understand also to understand the goals of the SEE. After this, we are diving deeper into the hardware, how we developed and how we assure the integrity and physical protection of the platform itself. And last but not least, we also have a look on the software stack that we implemented into the SEE, and I walk you a little bit to the trusted boot process to give you a better understanding what's behind the scene, what's going on when we are starting up the SEE and why the virtual environment is protected. And as I mentioned, after this, we are open to answer questions. Okay, motivation. So the need for a secure execution environment, from our point of view, it is time to rethink our security approach in our new connected world and new connected and smart environment. In the last webinar, we talked about the change in this, or the change in this landscape, and we talk about the decentralized approach versus the centralized approach of a data center, and how the today computer or computing power is managed and delivered to customers. And this is exactly the point where we think that, especially today, not only the data and information are in the focus of security, also the application has to move into the focus and have to be into the spotlight when it comes to security and when it comes to establishing trust in our new world. So, saying this, we also see that the threat landscape today is spread all over layers and all over the application stack and the computing stack itself, starting from the hardware and going up into the application area. So I think many of you, I hope in the audience, are very technical people, and many of you, they understand that starting on the hardware, we see the attack on hardware and firmware on chipsets. We see also attacks on the virtualization layer. Operating system was also in the past in the focus of hackers and threats and viruses and malware, and also applications by nature and then also from history on are in the focus when it comes to when attackers try to get access to an IT environment and then processing environment. And that is the situation today. And so we can either we start on the virtualization layer or the operating system layer. We can hook into the whole stack, and then we can access the application, we can access data, we can access information. And what happened, I don't have to tell you this. So that's the situation today. And that gives us at PrimeKey the motivation that it's time for a next level of trust in this environment, where we need protection of the whole technology stack in a processing environment. We call it secure execution environment that is able to shield application and the whole technology stack, application, virtualization stack, operating system stack against unauthorized access. That is the main overall goal of the secure execution environment. Very simple, but brand new, and I think it's today we only see in the security appliance market only some examples who are trying to achieve this, and so that gives us also the motivation to develop this. So here's the concept of the secure execution environment. As you see on the picture on the right side, we're talking about full-size rack-mounted servers, 2U high, and this server has to be FIPS 140 level 3 secured. That's all. So that means the hardware and software is protected, and the application that is running inside this server, or the application stack, is protected against unauthorized access from outside in any time or in any state of this application. That was a concept, and it is still the concept, and that is what we achieved with this secure execution environment. So let's talk about the design that gives you an overall understanding about what's inside these full-size rack-mounted x68 server. That's standard. So we are taking a standard motherboard that's available in the market, and that is our basic, where we are start to develop the secure execution environment. Full-size rack-mounted server. That's a platform. So inside this, we establish the secure execution environment. So the goal is to give virtual machines an application area or a runtime area where they can run safely and secure and are shielded and protected. And to do this, it says, okay, we will cover or we will shield the user applications, the virtual machines, in a FIPS protected boundary. That is a boundary where the whole application stack running in a virtual machine are protected and shielded against unauthorized access from outside, and they are secured also, so that you cannot manipulate these machines, and each time the machine is fired up, this integrity is checked, and we are sure that we have the same machines that we deployed up front in this environment. To enable this virtual environment, we decided to use our PrimeKey Secure Foundation Platform software stack. That's a learning from scratch, booting into a KVM virtualization layer. And this platform, it's the same operating system platform that we are using also in our flagship products, the PKI appliance, where the whole PKI eJPC stack is running. So, and we decided to use this so we have only one operating system stack that we are supporting and maintaining at PrimeKey itself. That's the underlying software stack and virtualization layer. To secure the integrity of the application, to secure the integrity of the operating system of the secure foundation platform itself, and to secure the whole environment, we need the so-called, we call it trust anchor. Now, we don't talk about the trust anchor that maybe you know it from the chip manufacturer like a TPM or secure element. When we talk about a trust anchor, we are talking about an additional processor or computing environment that is added to this physical protected environment itself. Later on, I will give you an explanation about this trust anchor. Designing this on our whiteboards and drawing this big picture, it was absolutely clear that we need something that is able to display the status of the runtime environment, of the physical protected runtime environment, something that is able, where we can do a minimum and control of this environment. And therefore we added, we called it PILO, the PrimeKey Integrated Lights Out system. And here we have the possibility to display also the status in front of the secure execution environment on the touchscreen panel, or we can also access this PILO from outside via a web browser and mirror the touchscreen display into the browser itself, so that we have a picture about the status and we can control the minimum. We have a minimized control. So, talking about the design, we will now start digging a little bit deeper into the hardware and how we developed and how we established the trust and how we established the protected environment. So another block diagram. So to derive from the first design organization. You see that we are talking about now on the hardware level. We have the x68 main board on the left-hand side of the picture, the gray part with the output connectivity of the 4 Ethernet cables and the 4 SATA cables to connect hard drives to this main board itself. And then we have the trust anchor. That's the second processing unit that comes also with the CPU, the RAM, and the flash device, and who is in the green area. And both of them are located in the physical protected environment. And here comes the principle of how we are setting up this, this hardware environment is that starting from the power supply itself of the server, this power supply is connected to the trust anchor inside this physical protected environment. The physical protection we establish with a hard epoxy resin potting process, so the whole system is potted, and there the trust anchor is controlling the power that is presented to the main board itself. So after the integrity check and check that is done by the trust anchor, and everything is in line with the policy and checksums are correct and everything, the power is switched over or switched on to the main board, and the main board is booted up. That is the main principle. And here we show you a picture of what's inside this rack-mounted server. So what we did is we are using, as I mentioned, we are using a standard Intel mainboard with a 4-core Xenon E3 processor on it and 64 GB of RAM and 128 GB internal storage. So we use this, and we are potted this with a hard epoxy resin, and we achieve the FIPS certification for this environment on the physical side. So that's the protected environment. And what you see on the picture itself is that on the right side down you have the Pilo who's controlling the touch panel. And this Pilo is connected to the board itself, and on the top side you see the Ethernet connection that are also access to the main board itself. So the first question when customers see this approach and understand our approach, the first question is, what about the heating? How do you get rid of the heat that's coming up from the mainboard itself, and how can you cool the mainboard when you are potting this? So therefore we place the fan directly in front of the heat things that we designed, so that the airflow is directly covered, or is directly goes directly over the cooling components, the heating that we designed. And on the right hand side, in the bottom area, you see an analyst analyzing a temperature picture and map of the secure execution environment when it's running under load, and you see that beside the heat pipes who are coming out of the epoxy resin and connected to the heat sinker, that are hot spots, and the other hotspot is in that the power supply of the server itself. So that is exactly that you see in which range we are now talking of. And so this is how we are sure that we don't run into overheat and we are running in a temperature collapse of this platform itself. Let's talk a little bit about the trust anchor. And the trust anchor, as I mentioned, is located inside this physical protected area, inside this epoxy resin potted area where the mainboard is located. Here you see, I put the picture of the trust anchor add-on board that we designed for this mainboard, for the standard mainboard. And as I mentioned, it's based on an ARM processor. And this truss anchor is actively controlling the power to the mainboard in an active way. So that means the ARM processor is verifying the stored boot images on the trust anchor itself. And after the validation is passed, he is switching on the power supply to the mainboard, and then he's presenting the boot image to the mainboard, and the mainboard can boot up the whole image and boot up the whole software stack itself. And that is an add-on board that we designed here at PrimeKey, and that is added to the standard x68 mainboard of the server itself. The operating system of the trust anchor is a embedded Linux system, and it's flashed on the chip during our production cycle. Yes, we are FIPS certified, so we achieved beginning of this year the FIPS certification, FIPS 100-2 level 3. So we are talking in the same level as a hardware security module vendor itself. And the trust anchor is also compliant with crypto operation, RSA, and all the hash families or that are defined in the NIST environment. Our security lab was Acum Security, who are supporting us in writing documents and supporting us also in terms of testing and validating. So let's talk a little bit about the firmware. So besides the hardware itself, so we have now we have established a secure execution environment, physical protection. We have established the shielding. We have a trust anchor that is on top of the main board, who has the second power, or has the second computing power. And with these components, we are now able to draw the whole picture of our initial design. So we have our application, we have our virtual machines that are running on our virtualization layer on top of our secure foundation platform, the Linux from scratch, that we are maintaining and we are supporting here at PrimeKey. Underneath, we have the trust anchor. And the trust anchor is also part of the physical protected environment. Inside the trust anchor, or at the trust anchor, we are storing the secure boot image of the whole environment itself. So that means the secure foundation platform, the operating stack, is stored inside the trust anchor, digital signed, and all virtual machines from the user are also stored inside the secure boot image on the internal hard drive and our flash memory of the trust anchor itself. And that is exactly the point where we can assure and we guarantee the integrity and that nobody manipulates the operating system or the SFP image of our platform, and nobody manipulates the user application, the virtual machine of the user itself. And that gives a full picture of the secure execution environment. So we are protecting it on a physical way. We are storing the boot images in the trust anchor environment and guarantee the integrity and the authenticity of this images in this protected environment. And once we are booting up, the customer can be sure that his application is not manipulated, is not modified, or it's not compromised. What happened when we are booting up the SEE itself? So starting on top of the diagram of the left-hand side. So once the system is off, we are connecting the power cord, and then the trust anchor will get his initial power. The main board is power. The main board is power off. Yeah. So the first step is that the trust anchor itself is start loading his own bootloader. Here we are using U-boot, and starting and testing his embedded Linux environment. Once this self-test is passed and it's valid and it's okay, then the boot images for the main board, the operating system, or Linux, the secure foundation platform from PrimeKey, and the virtual machines from the customer are tested and validated. The signatures of this boot images are validated, and if this signature is okay and not modified or not invalid, the trust anchor will go into the mode that he is starting to present the boot image as a USB device to the main board. Once we are powering on now the SEE via the display in front at the front side, or via the control environment that we are accessing with our browser, this boot image, as I mentioned, is presented to the SEE mainboard, and the mainboard itself is booting up from this USB stick that is presented by the trust anchor, and these boot images and also the virtual machines are verified before and are not compromised. And I also added some screenshots from the front panel itself to see. So in the first step, the SEE is only connected to the TA, and the environment is checked and everything is fine. Then after we are switching on the power, on the green button, so we are starting now and powering on the SEE, and the operating is booting up, and afterwards we are booting into the KVM, and then the virtual machines are coming up, and then it's fully in operation and everything is connected, and we can have access to the applications that are running on the server. From outside, it's look like a standard server that is starting, and applications are booting up. You can maintain your application, you can control your application like you are used to, like the application is developed. We don't modify anything on the application. So we are giving them a trusted home, we are giving them a trusted environment. That is the principle of the secure execution environment. And so to give you an example about typical use cases where this platform and this product is used today, so especially when it comes to uncontrolled environment like factories, like a factory in China, or also data centers in China, these technologies, these product platforms are used. So we have customers who are shipping their technology and their product stacks inside the SEE and directly into China, and this is the reason how to secure that nobody can copy, manipulate, or steal this application stack. On the other hand side, we are talking also about this, it's a buzzword, but we are talking about crypto agility. It's when it comes to re-encryption of key material, so that you are taking a key symmetrically, and you want to move it from, for example, from one hardware security model to another, you have to encrypt this key blob that you are retrieving out of an HSM, and then you have to decrypt this key blob with a new key that's in line for the new HSM where you want to import this key blob. And therefore you need a secure environment, because you have temporarily and for millisecond, you have your key material in plane. And you have two options. The first option is you have to protect your data center, and you have to protect the environment where the server and where the application is running. Physically with access control and many organizational stuff and very high organizational stuff. Or you take a secure execution environment, put the application directly inside this environment, and you run it in a FIPS protected environment, and you fulfill all the requirement of the auditor itself. But talking to this, I think if we are interested more into the use cases and of a secure execution environment inside the presentation here, you see a link to the last webinar we had 1 month before, when we talk about the use cases and application scenarios and how to typical applications that are running into a secure execution environment our customers are using today. And also you can read the report about how to simplify compliance audits with the secure execution environment, especially in the banking industry, when we are talking about the crypto eligibility, transporting key material, moving and migrating key material. So I hope I give you a better understanding of the secure execution environment itself. And I think if you have any question about what's inside the platform, what is the technology, what some details about operating system, I'm open for the question, and I'm happy to answer these questions. Otherwise, you can also drop me an email and we can get in contact afterwards. Thank you for this. And now I'm looking to Evangelos, and he will.
Thank you very much, Andreas. Some questions were asked. First of all, do you provide 24/7 support and maintenance services?
Yes, yes. Can you please close the microphone? You.
Okay. So the second one is there any limitation regarding the virtual machines like operating system?
Again.
Okay, is there any limitation regarding the virtual machines, VM, like operating system?
No, there is no limitation. And so you can take your VGI image from your virtual box environment, you take your virtual machine and put it on top of the KVM. There is no limitation of operating system.
Okay. Next one, do you see a use case within the industrial IoT market?
Yes, of course. Especially this is a typical environment where we are talking about uncontrolled environment when we are talking about manufacturing side. Due to the new trend that the internet is also support, or the internet is brought to the manufacturing side and the digital factories, we see more and more the requests from the market to provide a trusted environment to process applications, yeah, inside or directly inside a digital factory.
Fantastic. This was the last question. Thank you very much, Andreas.
Perfect. So we are at the end of the webinar itself. And as I mentioned, please. Oh, wait a moment. There is a question coming in, or?
Yes, there is a further question. Sorry, Andreas. Is the common criteria certification on the roadmap?
Not yet. Not yet. So we are talking also here in Germany with some customers who are looking into the area of government application and use cases, and there we have some requests about common criteria, but to be honest, as today, CC and common criteria is not on our roadmap.
So one last one. Is it possible to get the presentation webinar recording about the use cases?
Yes, of course, yes. The use case webinar is available. I think it's on our website, on the PrimeKey website. If you're going into the SEE part of under hardware SEE, and then when you're scrolling down the site itself, then on the bottom you will have a link to the presentation. Okay, perfect. So many thanks for participating in this webinar. And yeah, again, please drop me an email for some further questions. And many thanks for participating.